Hi, today we're going to be explaining the empirical rule, how it is used, and for what it is used. So first of all, the empirical rule says that in a normal set of data, virtually every piece of data will fall within 3 standard deviations of the mean. So I want to start by explaining what a normal set of data is. So a normal set of data means that the data is divided or distributed in a normal distribution. Normal distribution will look a little bit like this in a graph. This is what we call a bell curve, and the normal distribution says that the data will be 50% on this side and 50% of this side, the mean being the center. This right here is what we call a mu, and the mu is equal to the mean. So now let's move on to our second part of our definition, which says virtually every piece of data will fall within 3 standard deviations of the mean. Okay, so first, what is the standard deviation? Standard deviation can be portrayed as Greek letter sigma, which looks like this. And the standard deviation tells you how far away or close by our data is to our mean. So it's kind of telling you the real distribution of the data. So we know our data is symmetrically distributed. So if we go 1 sigma above mu, and 1 sigma below mu, this will be mu plus sigma, 1 sigma, and mu minus 1 sigma, and this will equal 68% of, so you have a 68% probability that your data will be within 1 sigma. So if we go further out, 2 would be another sigma, so it will be mu plus 2 sigma, or mu minus 2 sigma. Our data, all this, will be 95%. So there is a 95% probability that your data will be within 2 sigmas. And finally, if we go all the way up to here, so it would be mu plus 3 sigma and mu minus 3 sigma, there will be a 97.5% chance that your data will be within the 3 sigmas. So this is why it's called the 3 sigma rule, or 68, 95, 97 rule. So if you learn this, you will know that within 1 sigma, it will be 68. Within 2 sigmas, a range of 2 sigmas, it will be 95%. And within a range of 3 sigmas, it will be 97.5%. So as our definition says, most of the data will fall within these 3 standard deviations. Only another 2.5 is left. So you might be wondering what happens to this area right here. These are what we know as the tails of our graph. And what happens to this 2.5% that does not apply to the empirical rule? Well, we know that when our data is normally distributed, it has to fall within a certain range, and that is up to 97.5. All of the data that falls within these 2 areas are known as sometimes as the outliers. And they are so far away from our actual normally distributed data that they are not relevant. We get our 1.25 on this side and 1.25 on this side, and this would make the 100. So the empirical rule is obviously not used in every single case, and it is used mostly as when you want to make a rough estimate of where your data will be distributed. It is not as precise as other measures are, obviously, because it only tells you if it falls within a certain range, but it is good when you're estimating large amounts of data, and also if you want to test the distribution's normality. So if it's actually a normal distribution, most of the data will fall within these 3 sigmas, especially within the first ones. And yeah. So why is the empirical rule useful? Well, its primary use is to help determine outcomes or forecasts of where data distribution will lie even though we do not have all of our data available. So this can be used before data is collected to make a kind of guess of how the distribution of data will be. And also to know if our set of data is normal. So for example, if most of our data falls within our tails or the outliers, it means that the data is not normally distributed. So we would not be using the empirical rule, but other methods of statistics.
We're gonna be solving problem number 35 from the lab part 2. And the first insert A, asks for the probability of the mean being minus sigma and plus sigma. Here we have our bell curve, and we know that the mu is always in the middle because it's the mean. And since the bell chart is always symmetrical, we know that from here we're gonna have the first sigma, and then we're gonna have the second sigma, and then we're gonna have our third sigma. After we have this, we know that they're asking us for the mu minus sigma, so here, and the mu plus sigma, so here. So basically, they're asking us for this range. In the original theory, we saw that from here to here, it's 68%. From the second sigma to the other second sigma, it's 95%. And from the third sigma to the third sigma is 97.5%. So we know that they are asking us for the mu, which is the mean, minus 1 sigma and plus 1 sigma, and they're asking us for this range, then they are asking us for this percentage. So the answer to insert A would be 68%.
And what we're looking for is the probability.
The important step is recognize the percentages of the table. The table usually gives you 68%, 95%, and 99.7%. For this step, it's important that you consider that the table is symmetrical. So it will be the same this side than the other side. In the problem, they ask you to find -2 to positive. So in the chart, you have to recognize here. So you got 13.5 plus 34% plus 34%. This will give you 81.5%.
So what's the probability that x lies between mu minus 2 sigma? So what they're basically asking us is, what's the probability that the x is between here? Because we're subtracting 2 sigma from the mu. So we go 1 sigma, 2 sigma, and now they're asking us this area. So basically, if we divide this by the both sides, we have 2.35. That's the remaining from this one, and then we also have 0.15. That's the remaining to get to 100%. So if we add those up, it would be 2.5. So the answer would be 2.5%.
To solve problem D, I will have to use this chart, and the problem is asking me what is greater than this sigma. So this is located here, so it will be what is in this space. So it will be my answer will be 16%. And solving problem E, it is asking me what is between this space and this space, so I will have to add up all that is between here. But instead of doing it that way, I will do 100 minus what is outside of the space it is asking me. So it is outside 2.35, 0.15, and 0.15. So it will be 100 minus
0.15 minus 0.15 minus 2.35.
And it is 97.35%.